All right, in this worksheet, we're going to talk about conditional statement. From the previous worksheet, we talked about conditional statement a little bit. It's basically if-then type of statement. There's like if something something and then something something. It tells us what action to take based on the truth value of the condition. So, for example, if you do something, if you take out the trash, then you can have ice cream or something like that. We use that like all the time, pretty much, right? I'm sure at one point we have all told ourselves, if I finish so there's the if part, right? If I finish all my homework today, then I'll watch a movie tonight, right? So if then. It's an example of a conditional statement. So this is the definition of conditional statement again. A conditional statement is compound statements in which the statement P, called antecedent. Anti just means before. So this is a statement that comes before the second part. Usually, sometimes we write it as a P. So the antecedent P implies the statement Q, called consequent. So antecedent is the if part, and then consequent is then part, right? So if you do something and then. So from the previous statement, if I finish all my homework today, that's antecedent. And then I watch watch a movie tonight. So watching a movie tonight is the consequent. So consequent of finishing all your homework is watching a movie. That's why it's called consequent. Symbolic representation. P implies Q is written as P, letter arrow, Q. And it's translated if P, then Q, right? So a lot of times I'm going to write it like P, arrow, Q, and I'm going to read P implies Q, right? P implies Q. That means if P, then Q. Okay. All right, so there's a little note here. I want to say that I think it makes for a conditional statement to be true, if P happens, then Q must happen. So in order for if I do my homework today, then I watch a movie tonight to be true, if I did my homework, I kind of have to watch a movie to make that the whole statement to be true. So that's what it says here. For a conditional statement to be true, if P happens, then Q must happen. However, if P doesn't happen, then it doesn't matter whether Q happens or not. Either way, a conditional statement will be still true. All right, let's look at number 3. It says, when buying a textbook online, the website says, if, so here there's the if part, if you pay for expedited shipping, there's a comma, so there's like a then part indicated, you will get your book by tomorrow. So there's like if-then statement. So this conditional statement. This is my P, this is my Q, right? If you pay for the expedited shipping, then you'll get the book by tomorrow. So the question is, in what situation is the website telling a lie, right? So let's look at the part A. You pay for expedited shipping and you got your book tomorrow. Okay, that's fine. That's what they said. So they kept their promise. Part B. You pay for the expedited shipping and you did not get the book by tomorrow. Ooh, that's a lie. That means you pay for it, you should have gotten it by tomorrow, right? You did not pay for the expedited shipping and you get your book by tomorrow. I'm not going to complain. I didn't pay for it, but I got it by tomorrow. So technically they didn't lie because they didn't say anything about what happens when you don't pay for the expedited shipping, right? So I still get it by tomorrow. That's okay. You do not pay for the expedited shipping and you do not get the book by tomorrow. Well, okay, that's also okay. Again, they didn't say anything about what happens when you don't pay for the expedited shipping. So I'm gonna make a little note here. Part C is kind of a weird situation, so it's technically they're not lying, right? Not lying. Or L-Y-I-N-G. Oops, I don't know how to spell lying, I guess. Because they didn't say anything about what happens when you don't pay for the shipping, right? So the only lie for out of those 4 is part B. Okay, I'm gonna have you pause, work on number 4. We'll meet back at number 5. All right, so let's look at number 5 now. So this is this table you see is called a truth table for a conditional statement. In logic, again, this is truth table again, but with conditional statement. So it's a little bit more complicated than what we did last time. Not really complicated, but just different type. In logic, the only time the conditional statement is false is when the antecedent is true, but the consequent is false. So just like our example we saw here, in number 3, only time the bookstore or the website was lying is when the antecedent is true, where it means you pay for the shipping, and the consequent, which means you have to get the book by tomorrow, is false, right? So we're going to kind of translate that into truth table here. Let's zoom in a little bit. So again, we're going to kind of start. So I have statement P, I have a statement Q. So I'm going to kind of start the same way. T, T, F, F, and then T, F, T, F. Right? So again, only time this is false is when the antecedent is true, but the consequent is false. So that will be the second case. This is false. And every other statement is true. True, true. So I'll make the comments here. Here. Only time P implies Q is false is truth implies false, right? So I'm gonna circle this part. Everything else is true, basically. All right, let's look at the next question. Pretty complicated. Oh, here I noticed that we have 3 statements. So there's M, there's not P, and there's R. So this part is antecedent, and this part is consequent. So the structure of the truth table is pretty much the same. Since we have 3 statements, we need to have 8 rows to cover all possible cases. So the way I start, the first 3 are just M, P, Q. This part is pretty much fixed. So when I have 3 statements, all my truth table is going to start pretty much the same way. I go T, 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 F, 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 and then T, T, F, F, T, T, F, F, and then T, F, T, F, T, F, T, F. I know it seems all random, but you know there's a pattern. So first one is all T's and then all F's, and then 2 T's and then TF, TF. So it kind of alternates. This is so that we can cover every single possible combination of M, P, R. So the first row is M's true, the first statement is true, second statement is the third statement is true, and then so on and so forth to the case where all the statements are false. Notice that I have extra columns here because my antecedent is here, my consequent is here. So I need a row for antecedent right here, and I need a row for consequent, so right here. So basically I'm going to fill these columns at some point, and basically I'm going to kind of do the same thing. I'm comparing these 2 columns and see when I have true, false, and that's when the whole thing is false. So this one is a little complicated. I have to kind of build up to M and not P. So we have M already. I need not P. So let's look at P. So I kind of made extra column of not P. Here, if you can do it in your head, you can do it, but I just don't want to write everything out here. That's why I kind of made extra column for not P, the negation of P. So basically, P is TTFF, TTFF. So negation of P, not P, basically it's just flip that. So T, for T, not P, when P is true, not P, or the negation of P is false, right? Same thing when P is true, the negation of true is false. So I'm basically flipping all the letters because we're doing negation. All right. So now I'm ready to do this column, M and not P. From the previous section, when you have something and something, only time it's true is when both things are true. So I'm going to look at the M column. I have to look at the not P column. Maybe I can highlight it. This is my M column. This is my not P column. So I'm going to compare these two columns. It's this and that. So basically, I have to see when both things are true. That's when only time this part is going to be true. So I'm looking at this column. I'm looking at this column. When is it that they're both true? The third row, I have both true. What else? The next one is where we have both true. Is there anything else? I think this is it. So those two rows are only time where M is true and also not P is true. Everything else is false. False, 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 false. We have R. Again, I just made extra column because I want to see it visually, like antecedent and then consequent. I didn't have to do that, but I just want to do it, just make things a little bit easier visually to see like that. TF. Okay, so now I have my two columns I want to compare. I have my antecedent column. I have my consequent column. So again, only time the conditional statement is false is when I have true, false. So here I'm going to look for true implies false. That's the only time when we get, that's only case we get false, right? So comparing these two columns, do I see true, false, right here? I see here's true for antecedent, false for consequent. This is false. Do I see another true, false? I think that's it. So everything else is true. So true, 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 true. So my final answer is, the last column is my final answer, right? So this conditional statement is true for every cases, except only time is false is this one. So when M is true, P is false, R is false, then the conditional statement is false. Everything else, the conditional statement is true. All right, let's look at the next question. I'm gonna get you kind of started. I'm gonna have you guys finish by yourself. Here, let's look at the given statement. J's the statement that Jamie goes to the party. S, Stephanie goes to the party, and A, Alex goes to the party. It's the party question again. Rewrite the following statement into symbolic form and complete the truth table. Okay, so the statement is here. If Jamie okay, so this is the if part. Jamie doesn't go to the party, or Stephanie goes to the party. Oh, I noticed there's an or. Then Alex goes to the party. Okay, so this kind of statement, I want to like identify antecedent and then consequent. So I underlined if, underline then. So this whole part is antecedent. Antecedent. And then last part, the Alex goes to party, is consequent. Consequent. Okay. So when I make this truth table, again, the last two rows, the last two columns, I want it to be like antecedent column, and there's a consequent column, and then the result column, right? So the last three column, I know what it's going to be. So antecedent column, consequent column, and then the final answer column. Okay, so I'm going to keep that in mind. If I look at the antecedent, there's a Jamie doesn't go to the party, or, so I'm going to also circle this or, Stephanie goes to the party, right? So here, I'm going to make extra column here. I need Jamie doesn't go to the party, so negation of Jamie, so not Jamie. And then Jamie doesn't go to the party, or Stephanie goes to the party, so I need that column also. Not Jamie or Stephanie, so I need that column. So that's my antecedent column. And then I need my consequent column, which is Alex, so A. I'm just going to rewrite that. And then final answer column, which is the not Jamie or Stephanie implies Alex, right? So not Jamie or Stephanie implies Alex. So Jamie doesn't go or Stephanie goes to the party, then Alex goes to the party, right? So let me circle the antecedent column, and there's a consequent column. So I'll try to fill the antecedent column, I'll try to fill consequent column, and then again we kind of have to do the same thing. Look for TF, look for T basically implies F is the only case we get false. Okay, so I'm gonna have a pause, finish this question, and we'll meet back at the next question. All right, let's look at the next question. Number 8. For the statement, if you wash my car, so again there's if, comma, you will receive extra credit. They didn't say then, doesn't matter. If you wash the car, comma, you will receive extra credit. I can't imagine there's then part. So washing car is consequent, antecedent, and then you receive extra credit is consequent part, right? So W, wash my car, E, receive extra credit. Write down each symbolic statement in words, okay? So W implies E, okay? If, so again, the first part is antecedent, after arrow is consequence. So if you wash my car, that's the original statement, then you will receive extra credit. Like in logic statement, like the tense is not that important. So you can say, if you wash my car, you receive extra credit, or say you will receive extra credit, or you did receive extra credit. We can kind of mix the tense, whatever it makes sense. So tense is not going to be future, past, present is not too important in terms of logical statement. Okay, let's look at the other one. Notice that E is now the first antecedent and then W is the consequent. So we're kind of like opposite. So here I can interpret this as like, if you receive extra credit, then you wash my car. Here, I think this question makes more sense if you interpret it like this. If you receive the extra credit, then you must have washed my car, right? So maybe I can change my answer a little bit. Then you must have washed my car, or you washed my car. Okay. So converse, it's called converse. Converse is basically you're switching the consequent and antecedent of the original statement. So if you wash my car, you receive my extra credit. So if you get extra credit, then you must have washed my car, or you wash my car. Well, is that always true? I want you to kind of think about it. Is it necessarily true? If somebody received the extra credit, are you like, is this person guaranteed that this person did wash my car? Well, we don't know that, because it could be the possible, but are you 100% sure that's the case? No, because there might be other extra credit opportunities. Maybe this person did like an extra project or something. So we don't know for sure this person have washed the car. So I want you to think about that, about the converse statement. Now let's look at the inverse statement. So not W implies not E. So negate W. So negate wash my car. So I'm going to kind of the same thing. If you don't wash my car, then I need more space. You don't. Notice that there's not and there's not. So if you don't wash my car, then you don't receive extra credit. Credit. This might be the case, but is it like 100% always the case? Again, as I mentioned before, I mean, this person didn't wash my car, but maybe this person did other project, extra credit project, or whatever. So just because you didn't wash the car doesn't mean you can receive the extra credit, right? So the inverse statement, this is called inverse, where you're negating the antecedent and consequent. I want you to think about like how inverse is not always true, right? Contrapositive, not E. So if you didn't get extra credit, then you negate the W, you didn't wash my car. Then you didn't wash my car. Right? If you didn't get, so this person did not get extra credit. I know 100% sure that this person did not wash my car, but because if this person washed my car, this person would have gotten extra credit. So the fact that this person didn't get any extra credit, I know this person did not wash my car. So it's called contrapositive. So contrapositive is basically, according to the original statement, contrapositive is actually true. So I want you to kind of think about, we'll talk about this on next worksheet in more detail, but I want you to kind of think about different structure of this type of conditional statement. All right, now I'm gonna have you guys work on these 4 truth table, one for each type of conditional statement. So this original statement, there's a converse, there's inverse, and there's a contrapositive. So I'm gonna have you finish all 4. If you look at the answer column, you'll notice that 2 pairs will match up. So there are 2 of them will have exact same answer column, and 2 of them will have exact same answer column. I want you to kind of identify those 2 pairs. And I think that's it for this worksheet.